So, welcome back to my lecture series, YouTube lecture series. I am Dr. Sushan Lal Babu, Assistant Professor, Aerospace Division, Pioneer Institute of Technology and Science. Today, I'm going to take a topic on electroplating, and it is from the subject Essentials of Chemistry for Aerospace Engineers. Electroplating, from the name itself, we will get an idea that what exactly that process is. We are using electricity to plate something on some surface, okay, or some objects. So why we are plating, why we are coating this superior metal on the base metal to enhance the what properties, strength, or performance, or look, or aesthetic of any surface or any substance. Okay, that is the primary objective of electroplating, and we are using electricity for this purpose. That's why it is called as electroplating. So, we'll go to the definition of the electroplating. Electroplating is a process of coating a superior metal over base metal by passing direct current through electrolyte containing the soluble salt of the coating metal. So, there are superior metal is there, which is what we are going to talk. Which metal we selected to coat, means it has the uh, higher properties, higher strength. That metal we will select to coat. And over which we are coating, or which is called as substrate, okay, or base metal or inferior metal. And we are using electricity, DC direct current we are using, and we need an electrolyte which contains the soluble salt of the coating metal. Okay, so that is the definition of electroplating. Then, what are the main objectives of the electroplating? So there are some certain objectives provided there. One is corrosion resistance. So, we need to improve the corrosion resistance of the metal. For that, we will do chromium and nickel coated components. We have seen chromium coated, nickel coated components in automotive applications in cars, bikes. We use to coat chromium for protecting it from corrosion and for aesthetic appearance. So that to improve the appearance of some metals, we will use this particular technique or a process where we can coat gold covering, or we can coat with platinum, or we can coat with silver. So that depends on our budget. So it will improve the appearance of the metals. And third point is to increase the thermal conductivity of the metal. So you might have seen in kitchen utensils that some of the kitchen pans will be coated with copper. Extra coating of copper will be provided at the bottom of the vessels. For improving thermal conductivity, it will increase the efficiency while doing the cooking. Fourth point is to increase the tensile strength of the metals. So to improve the tensile strength, we use aluminum as the superior metal. We use aluminum will be coated over the substrate. Next, a simple example explaining of the process electroplating process of copper, and the figure is given below. So, what are the important things we need to have? Anode has to be there, cathode has to be there, electrolyte. Okay, so anode can be coating metal or an inert metal. Cathode article to be coated. So, what we want, which metal or which pan if we are coating a pan, if you are coating a pan with copper, then that pan will be kept as cathode. That electrolyte here we are coating copper, then copper sulfate is considered as electrolyte here. So in the picture we can see the anode. Uh, Here anode is used as a copper coating metal, or instead of copper coating metal, we can use graphite or platinum as inert anode. Okay, that is another case. Anyway, here we are using copper as the anode. Okay, so what will be happening? So if we connect the both anode and cathode with a DC source, then what will happen? This copper sulfate will decompose to Cu2 plus plus SO4 2 minus, and this is positive ion, so it will get attracted towards the cathode. So it will go towards the cathode, and it will get reduced and deposited over the cathode. That is the thing happening. So for reducing this copper to electrons, we need, so how these electrons are generated here. So that reaction is happening because of this SO4 2 minus will be attracted towards the anode, because it is negatively charged. It will get attracted towards the anode, and what will happen here? Copper will combines with SO4 2 minus to form copper sulfate by releasing two electrons. That means SO4 2 minus will get reduced by releasing two electron here sorry, it will get oxidized, because release of electron is always oxidation. So this will get oxidized by releasing two electrons here, and it will go to the cathode, where these electrons, copper 2 plus will receive this two electron and get reduced and get deposited over the pan or cathode. That is the overall reaction happening inside this process. So we will explain one by one. So when direct current is passed through CuSO4, it decomposes into ions. CuSO4 becomes Cu2 plus plus SO4 2 minus. Then at a cathode CO2 plus ions get reduced to Cu and get deposited on the article. It receives these two electron and will become Cu and deposited on the article. And at anode is a coating metal, copper. So first case, copper, it is anode. That metal, same metal which we are using for coating, will be considered as anode. So copper gets oxidized to form Cu2 plus ions, and SO4 reacts with SO4 2 minus. So copper will get oxidized and it will combines together with SO4 2 minus to form CuSO4, plus two electrons will be released. And if the case is second case, case 2 means anode is an inert metal, then we will consider we have to add more concentration of CuSO4 to maintain the to continue the process, because if we are using inert metal means copper sulfate will not be formed continuously. If we are using copper as anode, then copper sulfate will be continuously generated. But here, if you are using an inert metal, then copper sulfate will not be continuously generated. We need to add externally to maintain the concentration of CuSO4. Then, what are the important factors which affects electroplating? First one is temperature. When the temperature increases, amount of deposition increases. Both are proportional to each other. Concentration. The concentration of the electrolyte is higher, then that means more amount of deposition will happen. Okay, then distance between the electrodes. If the distance is very close, then it will enhance the deposition rate. If the distance is too large, means it will decrease the deposition rate. Time also, we are providing more time, means more deposition will happen. Less time, less deposition only will happen. And current, if we are if the current supplied is higher, then amount of deposition increases automatically. Last point, surface area of the anode. If more surface area is there for anode, means more oxidation will happen for copper to Cu2 plus will be generated, more and more electrons will be released, and accordingly more reduction will happen across the cathode, and more deposition can occur in the cathode. Okay, so surface area of the anode increases, means amount of deposition also increases. Then disadvantages. So major disadvantages is that because it is very expensive and it requires electricity and it consume time, then it another major one of the major another disadvantage we need to always remember is that it is non-uniform. Ununiform coating will happen. And then last one is electroplating bath solution has to be disposed carefully, as it is prone to water pollution. So these are the major disadvantages. And we have gone through the definition of electroplating, then how this with an example of copper plating we have explained what are the processes, what are the reactions happening at anode, what are the reactions happening at cathode, and what are the reactions happening within the electrolyte. And we have explained the major factors which affects the electroplating. Then finally we explain disadvantages of electroplating. So thank you.